Okay, are you familiar with the term Pemdas? Okay, we can use Pemdas written 2 letters per line to help us remember the properties of exponents. So if you see parentheses, you multiply the exponents. If you see multiplication with the same base, you add the exponents. If you see division with the same base, you subtract the exponents. So whatever is directly below the thing that you are doing, that's how you treat the exponents. Some of you don't need this. Some of you will use this visual tool to help you remember what you need to do. So number 1, I see multiplication with the same base. That means I'm going to add my exponents. So what is -2 plus -4 plus 3? Z to the -3. Now, we are not going to tell which properties you used because we're not going to write a proof. We are going to show every step, and you should add to the directions that your answers must have positive exponents only. So if you do use one of the properties and you end up with a negative exponent, you have to fix that negative exponent by using the negative exponent property. So 7 to the -3 becomes 1 over 7 to the 3rd. Once your answer is written with no negative exponents, you're good. Okay, number 2 looks complicated mainly because it's all kind of smushed together and harder to see. So I'm going to write this out a little bit more spread out. We've got y. How many factors of y is that right now that I just wrote? 1. So if you don't see an exponent on something, go ahead and put an exponent of 1 on it. That will help you, especially if you struggle with this at all. Then we have z to the -2. Next, I see parentheses with an exponent outside of the parentheses. If there's an exponent outside of the parentheses, we multiply that exponent to the exponents inside the parentheses. That would make this be x to the 6th, and this in here is y to the 1st, so that would be y to the 3rd. And then there's a z outside of there, and that is a z to the 1st. You also want to write your answers whenever possible in alphabetical order. So the x's need to come first. So if I look through here, we just have x to the 6th. Next, I look at my y's. We've got y to the 1st times y to the 3rd. What is y to the 1st times y to the 3rd? Y to the 4th. Then I look for my z's. I've got z to the -2 and z to the 1. What is -2 plus 1? Can I leave my answer as x to the 6th, y to the 4th, z to the -1? No. But it's important to know that z to the -1 is the only thing that has a negative exponent. So x to the 6th and y to the 4th stay on top, and z to the 1st goes to the bottom. You do not have to write the exponent of 1, but I would not count it wrong if you wrote a 1 there. Okay, number 3, I see parentheses with an exponent outside of the parentheses. So we need to multiply that -2 to all of the exponents inside the parentheses. Now, it's important to note that the 4 and the x squared are different. They are not connected. They are being multiplied together. This is a 4 to the 1st and an x to the 2nd. So when you multiply that exponent in, we end up with 4 to the -2, x to the -4th, because 2 times -2 is -4. And then for y, we multiply -3 and -2 to get y to the 6th. The 4 to the -2 is a negative exponent, and x to the -4 is an exponent. So y to the 6th needs to stay on the top. 4 squared and x to the 4th would be on the bottom. This particular example has both numerical bases and variable bases. If you have a numerical base like 4 and a variable base like x, y, whatever, if you have those in the same problem, definitely do the computation. So what is 4 squared? 16. So this is y to the 6th over 16x to the 4th. If I give you an example or a homework assignment where it's only numerical bases and there's no variables whatsoever, you can leave it as numbers and exponents because I mainly want to see that you're using the properties correctly. Not all teachers would tell you that, but that's how I would like to see it. But when you have numerical and variable bases in the same problem, actually compute those numerical powers. All right, number 4 is almost identical to number 3. It just happens to have a little division bar in there, which is no big deal. So try number 4 on your own. There's parentheses, so we need to multiply this -6 exponent to all of the other exponents. Keep in mind that it's not 2y to the -1, it's 2 times y to the -1. So we have 2 to the -6th, y to the +6th, over x to the +18th. 2 to the -6 is a negative exponent. It needs to move to the bottom. So we have y to the 6th over 2 to the 6th, x to the 18th. We would then compute to figure out what 2 to the 6th is. I believe it's 64. Y to the 6th over 64, x to the 18th. Number 5 looks complex, but we're going to go through this piece by piece by piece. This lines up vertically. First, we're looking at 18 over 24. If you do not know how to simplify fractions in your calculator, I'm about to teach you so that you don't have to physically simplify fractions on your own ever again. If you have a scientific calculator, you would punch in 18 ABC button 24 and then hit equals, and your calculator will simplify that fraction for you. If you have one of the newer graphing calculators, like the picture on my wall, there is a kind of a hidden function. The fraction function is kind of hidden. Alpha y equals. If you push the alpha button and then the y equals button, it pops up a little menu that has fractions. You can select that first option, enter 18 over 24, and hit enter, and it will simplify that fraction for you. If you either don't remember where that function is, or if you have an older graphing calculator, you can always do 18 divided by 24, get a decimal, then push your math button. Your very first option under the math button is change to fraction, and that will change it to a simplified fraction. 18 24ths simplifies to 3/4. So we have 3 on the top and 4 on the bottom. Next, we look at the x's. We have x to the 4th over x to the -4th. And some of you are thinking, oh, hey, they cancel, but they don't. X to the 4th divided by x to the -4th. When we're dividing with the same base, what do we do with the exponents? So what is 4 minus a -4? 8. This becomes x to the 8th. Now, here's another way to think about it. Negative exponents move. So x to the -4th on the bottom would move to the top and be x to the +4 on the top, and then you'd combine x to the 4th and x to the 4th to get x to the 8th. So if you don't like the subtraction thing, you can always use what you know about negative exponents to help you figure that out. Next comes the y's. Y to the 6th over y to the 3rd. 6 minus 3 is 3, so this is y to the 3rd. Or you could think about there's 6 factors of y on the top, there's 3 factors of y on the bottom. The 3 on the bottom are going to grab 3 on the top and cancel them out, leaving you with 3 left on the top. And lastly is the z's. Z to the 3rd divided by z to the 3rd. Z to the 3rd divided by z to the 3rd cancels each other out, and it's just 1. This is my rough draft. It's not the prettiest version of my answer. My answer is 3x to the 8th, y to the 3rd, all over 4. When I see parentheses with exponents outside of the parentheses, my first instinct is, let's deal with those parentheses. So we're going to multiply the -2 to all of the exponents inside. That will give us x to the 4th, y to the -12th. On the bottom, same thing. We multiply the 3 and we get x to the 9th, y to the 15th. Now we can match things up vertically and subtract. X to the 4th over x to the 9th. We would subtract 4 minus 9 to get x to the -5th. Then we would match up our y's and subtract. -12 minus 15 is -27. These are both negative exponents, so they both end up on the bottom, and you put the identity 1 on the top. Okay, alternative method. The place where I highlighted, you could just think about the 4 x's on the top, cancel out 4 of the 9 x's on the bottom, leaving you with 5 x's on the bottom. The 15, or the y to the -12th, that would move to the bottom and become y to the +12th, and then you would combine the 12 and the 15 y's to make y to the 27th. Another alternative method, going back to the very beginning, you could take that parentheses raised to the -2 and move that whole thing to the bottom and then do all of your work on the bottom while you just have 1 on the top. So there's at least 3, probably even more, ways that you could solve number 6 and get the right answer. Okay, turn the page. We're going to do number 7. We're going to skip number 8. When you have 2 or more fractions with a whole bunch of exponents, what I want you to remember is numerator is a numerator, a denominator is a denominator. So it doesn't matter which numerator it's in, it's on the numerator. So we have 20 on the top, we have x to the 14th on the top, and we have y to the 10th on the top. On the bottom, we have 2. Line it up with the number from the top. Okay, now x's. We've got x to the 3rd from the first fraction. We've got another x in the second fraction. So how many factors of x do we have in the denominator? We have x to the 4th. Now let's look at how many factors of y we have in the denominator. There's 6 factors of y in the first denominator, 9 factors of y in the second denominator. So how many factors of y do we have in the denominators? 15 of them. And now it's a problem just like we did before. What's 20 divided by 2? 10. X to the 14th divided by x to the 4th. 14 minus 4 is 10. So this is x to the 10th. Or think of it as the 4 factors of x on the bottom cancel out 4 of the 14 on the top, leaving you with 10 factors of x on the top. For the y's, 10 minus 15 is -5. And then you put that on the bottom, so you have 10x to the 10th over y to the 5th. If you don't want to mess with the negative exponents, think of it as the 10 factors of y on the top cancel out 10 of the 15 from the bottom, leaving you with 5 factors of y left over on the bottom. It's kind of like division with remainders. If you would like to try number 8, I definitely have the answer at my desk. You can check that with me if you'd like, but we aren't going to do it.